there must be a gap created in this region. Okay, so that gap is being filled by the surrounding air. So there's a continuous flow of air in this region. That is clear or not?
Sir, can you explain again?
Yeah, look here. What is happening? Warm and humid air, it rises up. You know that the process of cloud formation, it is very simple now. आपको पता है cloud किस तरीके से form होती है? You know that? Yes,
हाँ, sir.
Sundos.
Yes.
So cloud is formed due to the rising of warm, humid air at the upper levels of the atmosphere. Cloud is formed. Getting it now? Now, what happens when the process of condensation takes place? What will happen? The water will start. Water vapor will be converted into raindrops. Also, the temperature here will start to lower down. So the air will be cooler. The cooler air will start to move downwards, bringing rain. Is it clear? So two things are there.
Yes.
First thing is that warm air rises up and it forms cloud, and the upper layers of the cloud generates positive charges, while when condensation happens, the water droplets are formed. जब condensation होती है, water vapors changes into raindrops. Okay, and obviously it's raindrop and condensation has happened, so the temperature of the air will be lower down, so air will become cooler here, so it will start to come back as rainfall. So rainfall, the rainfall water is cooler now, it is colder, right? So you see here there is a generation of charges here. The raindrops are coming downwards, and during that time it is basically rubbed against the cloud. So there's a generation of charges. We know whenever there is a rubbing between the two particles, there is generation of charges now. जब दो substances को हम rub करते हैं, charges की generation होती है. Yes, Sundas?
Yes.
So there is generation of negative charges also. So since, and when what happens when the negative and the positive charges comes in contact, there is a generation of huge amount of charge that you see in the form of lightning. Is that clear?
Okay. Yes.
Yeah. Okay. Please explain to me. Explain करें आप how thunderstorm is forming.
Clouds has positive energy like in the up, and in the down it has negative energy, and it is having cool rain.
Okay. Okay, the basic thing here is that when there's rubbing of the positive and the negative charges, then there's a giving, then a huge amount of charge is generated, and that charge which is generated, you see it in the form of lightning. Okay, so you see what happens. This is an event in the environment in which strong winds blow accompanied by heavy rainfall. So whenever there is thunderstorm, you must have seen that there is a strong wind also. Yeah, so there is a strong wind also, there is heavy rainfall also. So you must have observed that as well. So during a thunderstorm, what is happening? Water releases heat when it changes from vapor to rain in the atmosphere. Yes, Chakrika, how are you? Yes. So imagine.
Can you say that again?
Yeah, sure.
What were you see?
Okay. Yeah, sure. Suppose you have water here in a tumbler and you are boiling it. So boiling it means you are providing it with some amount of heat. Water molecules are absorbing that heat now. Okay. And the water changes into water vapor. Did you guys ever imagine where did this heat went into? ये heat कहाँ गई? Where did this heat went?
Air absorb. I mean, the water absorb the heat.
Exactly. Water absorbs the heat here. That is what has happened here. Water absorbed the heat and it changed into water vapor. Okay. So far everything's clear. Now this water vapor being lighter, it will start to rise up. Imagine instead of boiling, the water is being evaporated here from vegetation, from water bodies. Vegetation and water bodies. Water vapor is evaporating. Yeah. So what happens during a thunderstorm? You guys know we were talking about thunderstorm. What happens? The warm air that rises up, it changes into I mean to say it changes into clouds there, and it releases the heat which it gained during the process of evaporation. In the process of evaporation or in the process of boiling, whatever heat was being gained by the water molecules here, it is being released when there is rainfall. During the time of rainfall, all that heat generated during evaporation by the water vapor is being released back into the air. Yeah. So the heat that is being released by the water vapor. Let me re-begin. I guess you guys are getting confused here. Huh? You have, vegetation here or water bodies. During daytime, evaporation takes place. Yes, Sundus and Chakrika, evaporation is
Yes.
taking place. So what is happening? Water is evaporating from both vegetation and from water also. So water vapor is there. Okay. And the sunlight is actually heating up the vegetation now. Sunlight is heating up the vegetation and it is heating up the water also. Okay. So water from water bodies or from the vegetation, it starts to convert into water vapor, and it has actually gained the heat. So it is not only water, it consists of heat also. It has heat in it also. Now what happens? This warm air, as you know, this warm air, it will tend to rise up. Okay, and when it rises up, it forms cloud. There is formation of cloud. All right. And
So do
then
you
what?
mean like when the water vapor rises up?
Water vapor, it rises up, no?
Yes, sir. So then it forms clouds, right?
When water vapor rises up in the upper layer of the atmosphere, it starts to accumulate together and form cloud. Okay.
Okay, sir.
All right. And now during a rainfall, what is simply happening? This water vapor in the cloud, it releases heat. The heat which it gained during the process of evaporation. जब evaporation हो रही थी, when there was evaporation, the water vapor had gained heat. Now, when the rainfall occurs, it actually releases the heat. I'm actually about to discuss how rainfall actually occurs. So the water vapor, it releases heat. So when it is releasing the heat, the air molecules nearby the clouds, they will become warmer. Yeah. So water releases heat here when the water when it changes from vapor to rain in the atmosphere. So when this
So
water
like
vapor changes to rain, it is releasing a huge amount of heat, and this warms the air around and creates a drop in pressure. Yeah. Sundus, you were saying
like
something,
when
or
it yeah. So like when the cloud releases rain, then
hmm,
it releases heat also,
it releases
as
heat
well as
also, and there is a drop in
as
pressure also.
exact timing.
Hmm. Not exact timing, it happens in a sequence manner. Okay. So when the heat is being released here, I mean, the conversion is taking place now from water vapor, it changes into raindrops. Okay. And while doing so, it releases heat. Okay. And if heat is released, it means the air molecules there above in the sky, the air will be heated up. Okay. So that means the pressure will also be lowered down. Yeah. Look here, if the air molecules around the cloud will become warmer due to the release of heat, the pressure will be lower down now.
Yes, sir.
More temperature means lower pressure. So due to
Yes,
lower
sir.
pressure, what happens now? It causes the air to rush in towards the center of this storm. So whenever you have, for example, whenever you have a storm in thunderstorms, the term itself is thunderstorm. Now see, thunderstorms, that is thunder plus storms. Okay, and you know it is accompanied by heavy rainfall also, there is thunder also. Okay, now talking about this, when the pressure is lower down, what happens? The surrounding air starts to gush in. It rushes towards the lower pressure region here. Why is it so? Because in the surrounding region, the pressure is higher. Higher pressure is there in the surrounding region. So from higher pressure to lower pressure, there is a movement of air in towards the center of the storm, and it generates a cycle. There's a continuous movement of air molecules from higher pressure to lower pressure, and this generates a cycle which causes large lower pressure system. It causes a very large lower pressure system which is accompanied by strong high speed winds, and it starts to swirl around it. Getting it?
Yes, sir.
Okay. Now, I hope thunderstorm is clear. It is simply thunder plus storm accompanied by heavy rainfall. That is simply the concept of thunderstorm. Now the question is here now, when does this thunderstorm becomes very dangerous and converts into cyclone?
Like when it's like having very much moisture in it.
Where when there is very much moisture in it, usually what happens in the tropical regions, when the temperature of the land surface, not the land surface, the water surface, if you have to look at the water surfaces, if the temperature of the water surface, water bodies reaches 26.5 degree, if it is about 27 degrees Celsius, especially in water bodies, then the phenomena of cyclone happens. Let's discuss the phenomena of cyclone in detail. Okay, by
What
the way,
is like the average percentage of the, like you
Mhm.
said, ocean?
It's 27 degrees Celsius. If the temperature rises about 27 degrees Celsius.
Okay.
Okay, we are coming to that. Okay, but before that, let me conclude the thunderstorm. Thunderstorms, you will see, it will develop in areas that are very hot and humid. It will not develop in a region which is dry and cold. It will always develop in areas that are very hot and humid, like India here. Okay, you see the high temperatures here in India creates strong upward currents, strong movement of airs upward that carry water vapor to high altitudes where they condenses and fall down as rainfall again. Okay, now due to the such drastic pressure variations, they are accompanied by lightning and strong winds also. The question is, normal rainfalls are there. How does that normal rainfall converts into thunderstorms? It is when the conditions are such that the normal rainfall, if it is accompanied by high wind also, like these are two clouds, rainfall is there. Now suppose high wind is blowing with high speed here, then the two clouds will rub against each other. No, they will collide against each other. So that will lead to generation of thunder. Getting it?
Yes, sir.
Okay. No, as in the previous class, I think Vaika has joined or not. I think she is absent today. No, she hasn't joined yet today. So one more thing I told in the previous class, that the temperature of the lightning, whenever there is a lightning, the temperature generated during that time is 27,000 degrees Celsius. Imagine the amount of energy it consists of. And imagine if humans were to harness this energy. Yes. Just imagine if we humans were able to store this much of energy that is generated during lightning. But the thing is that we haven't developed any such mechanisms to be able to store such huge amount of energy. Getting it now? So rather, it's better to mount buildings with poles so that this much of heat or temperature it is transferred to the ground. Okay, so that's why you see if the lightning falls on any taller trees or any taller objects, that object is destroyed. Okay. What are the precautions that one needs to take care of when there is a thunderstorm? It is as follows here. One should not take shelter. One should not take shelter under an isolated tree. Okay. Why is it so? One should not take shelter
And
in an
also like
isolated tree.
pole,
Yes.
and also an electrical pole.
Hmm. Exactly, and also an electric pole as well, because the
The
lightning that
block.
is generated during the process of thunderstorm, what happens? It looks for the shortest path to be conducted into the earth. This lightning will look for the shortest path to be conducted into the earth surface. So if there is two objects, it will obviously fall in the taller object because that is the least pathway for it to enter into the earth surface. That is clear?
Sir,
Mm-hmm.
can it also be like, because of like the tree trunk?
The tree's trunk.
Yes, sir.
The tree's trunk, it's not about tree trunks, or it's also not about whether the object is a conducting body or non-conducting body. The only thing here is now it actually looks for any object that is taller, which is the tallest object in that area. So it will be conducted into that body, no matter whether it's a tree or whether it's a pole. You see, a
Okay,
tree
sir.
and pole are two complete different things. One is a conducting body, while the other is a poor conductor. Okay, so tree being a poor conductor, still lightning is conducted by the tree as well. Okay.
Sir, I have a doubt. Like the people say they do not like have
Hmm.
phone at like you have a call, you are attending it. Like you don't. But why? Because it does not have like the least like tree. But why people say like we should not take the call on the phone when it's not needing calls?
Okay.
Like
Earlier you had wired telephones. Earlier you had no wired telephones. Remember? Nowadays it is not used. Okay. So wired telephones had their connections with poles. Okay. And some of the connections were underground as well. So now pole being a taller object, electricity will be conducted into that, and electricity will come to the wired telephones as well. That's why it was advised not to use wired telephones, especially when there is lightning. Got it, Sundus?
yes,
Sir, but then they also say not to use your phones also, right?
Nowadays, the phones which we use,
Yes, sir.
yes, smart.
Sometimes they say that we can't even use our mobile phones.
no,
So
that is absolutely senseless, because you don't have any wired connection now. The smartphones which you are use, it is not connected via any wire to the I mean the tower, cell towers. Okay, if there is a cell tower, okay, Also, the cell towers are made in such a way that the lightning will be conducted back to the ground and the tower itself is not damaged. Okay. If
Okay,
you
sir.
were to see clock towers, clock towers, clock towers or the lighthouses, they are the tallest objects in any given area. And they will be especially made in such a way that iron conductors, iron rods are attached on top of them so that lightning is easily conducted into them and it goes to the ground. That's why you will see now the houses are mounted with a conductor. You will basically place a iron rod on top of the house and it will be buried in the ground. Okay, this is iron rod here. So that what happens whenever there is a thunder, whenever there is lightning, all the charges are transferred to the ground and the building does not collapses. Getting it?
Yes, sir.
Yeah.
So
Yes,
then what
sir.
about windmills?
Windmills also, they are also made in a such a way that they have got conductors. Okay, so that all the charges passed into the ground and the structure itself is not damaged. Right. That is actually a genius idea. Earlier, the buildings were being destroyed by lightning. Lightning has so much of energy in it that it can destroy buildings. Right now. Okay.
Okay, sir.
So one should not also lie on the ground. Okay. Or one should not also be near by a water body also. Getting it now? Okay. One should not also be carrying an umbrella because if you were to hold an umbrella, it will obviously it has got a metal conductor also, and the height of the umbrella is slightly more than yours height. If you are holding it like this right now, so obviously lightning looks for the shortest path to be conducted into earth. So while holding the umbrella, you will be providing lightning with the shortest path. Getting it now? One should also stay away from windows and doors at that time as well. Okay, one should not take shelter in open garage where metal sheds are used. Okay, also it is advised to not take bath during lightning. Okay, if accidentally, let's say this is the water tank and somehow it is struck by lightning, it means that the tap water, it is also consisting of that electric charge in it, so the person might get electrocuted. Getting it now? So earlier people used to die of lightning, but nowadays there is almost few cases, one or two cases in a year. So now the question is that this cyclone, the topic which we are going to study, earlier it is thunderstorm. Cyclone begins as a thunderstorm. It begins as a thunderstorm. So thunderstorm converts into cyclone. During a thunderstorm, what happens? Water releases heat when it changes from water vapor to rain in the atmosphere. Yes. The heat
Yes.
gain, the heat gained by the water
Yes, sir.
vapor during the process of evaporation, that heat is being released back into the atmosphere during the process when water vapor converts into raindrops. So what happens? This is a cloud here, let's
Or I
say.
have a doubt.
Yes.
Sir, will the heat reduce after it starts raining, or will the heat reduce before and after that the rain starts?
Okay, let me clear it. Look here. When the when the water vapors have risen up, it accumulates and form clouds, the basic things. Okay, at the higher levels of the atmosphere, basically temperature is lower. First thing is, at higher level temperature is lower. So at lower temperature, condensation takes place. The condensation has happened. Then what happens during the process of condensation? What is happening? Earlier the temperature was lower. Okay, the earlier the temperature is lower. That's why the condensation has taken place. Now what is happening? This water vapors present in the cloud is converting to what? Raindrops. Okay. Now, due to the conversion of water vapor into raindrops, heat is being released. Yeah. So now what happens, Yokrika? The heat of the surrounding air is increased. It is warming up. Is it clear now?
Yes, sir. I mean, like, so when it rains, we don't feel that hot, right?
We don't feel that hot because the cold water is pouring on us, while the heat is limited to the upper portion of the air also only. Okay, it is not the heat that the raindrops carries along with it. The
Okay, sir.
surrounding, because if the water vapors to be if the raindrops were to gain heat, it will again convert back into a water vapor now.
Water vapor. Yes,
Exactly.
sir.
So it
So,
is able to fall down because condensation has taken place and its temperature has been reduced. Yes, Shafika.
so the heat goes up and then the raindrops come down.
Exactly.
Okay.
Raindrops comes down and the heat is spread into the atmosphere there. So this warms up the air and it will create a drop in the pressure. The pressure is
Okay, sir.
drop. Sundos, is it clear?
I didn't understand.
Okay, let me quickly revise it. Look, the water vapors here are rising up. Yes, so much of water vapor accumulates and forms cloud. Yeah. Then condensation takes place. Usually at the higher levels of the atmosphere, the temperature is lower. So condensation is taking place. So during condensation, what is happening? The molecules of water vapor are being converted into water drops. Water vapor molecules are converted into raindrops. And as you already know that in this process of evaporation, water that was being converted into water vapor had gained energy now. Now again, the reverse is happening here. This water vapor is being converted into water here now, into raindrops. So that energy is being released into the surrounding air. Now the temperature of the surrounding air will start to increase. So if the temperature increases, it means the pressure will drop. Is that clear now?
Yes.
Okay. So now, since the pressure has dropped, what will happen? It will cause the surrounding airs to rush in towards the center. The air from the surrounding from this side, okay, and from the this side, it will be rushing into the center. Why is it so? Because the surrounding airs are cooler. They are having more pressure, and there is always movement of air molecules from a pressure of higher region to lower region. Yeah.
So can you say that point again?
Mhm. The air molecules which are which are surrounding this cloud, they are cooler here. Okay, they are more colder. So more cooler, it means their pressure is higher now. They are having a more pressure. So surrounding air molecules starts to move towards the center of this cloud basically. That is having a lower pressure. You guys know the movement of wind takes place from where to where? From a region of higher pressure to lower pressure.
Yes, sir.
Yes, no?
Yes.
Okay. So suppose now you are having a container, okay, and you have filled it with let's say LPG. Okay, as soon as the nozzle is opened up, it is the smell of the LPG spreads to the whole room or in fact whole building.
What
Why
is
is it so?
LPG?
Liquefied petroleum gas. In our
Okay.
LPG is used now in our kitchens. The fuel that is used for cooking. So LPG is stored in the cylinder. If suppose someone opens the nozzle, don't try this. If suppose someone opens the nozzle, so gas molecules can be smelled from any part of the room. So earlier it was stored in only a small cylinder here. Now the smell can be heard in all the building. From any part of the room, the smell can be heard. Why is it so? Because earlier it had a high pressure, because so much of molecules were accumulated in a small region. Now, due to the opening of the nozzle, the gas molecules are spreading to the larger region. So here, what is happening? Earlier it was stored at a high pressure. Now, since the molecules are being spread to a wider area, now the pressure is dropped here. Same thing happens here. This cooler air, it is having a higher pressure because more air molecules are concentrated at this region. Getting it now? While here, air molecules are not very much concentrated. They are at somewhat distance from each other. Hence, they are having a lesser pressure. So the air molecules from this region will try to spread. So they will spread where? Where there is availability of a space. So here there is availability of space in this region. Let me point it out. Here there is availability of space. While here the air molecules are very much concentrated. So air, as you know, it tends to expand. So from this region, it will start moving towards this region. Is that clear?
Yes, sir.
Yeah, Sundas, what about
Yeah.
you?
Yeah.
Okay. Now what will happen now? There are factors like, Earth Earth rotates on its axis as well. Okay. So due to rotation of Earth, there are several regional disturbances as well here. What happens? The Earth is rotating on its axis as well. And the air molecules are moving towards this pressure of low region also. So what is happening? Air molecules are moving from here also. So this leads to a continuous cycle. Okay. So that generates a cyclone here. So what is cyclone here? Cyclone, you can say that it is simply a large mass of air that rotates very violently. The speed could be up to 1000 km per hour. Okay. Via animation, it will become more clear to you guys. Look at this animation. It will become more clear then.
There are three basic stages in the life of a tropical cyclone: its origin or source.
First, tell me, is the voice audible or not?
Yes,
It is
sir.
very good.
It is
Audible.
available. Oh, okay then.
There are three basic stages in the life of a tropical cyclone: its origin or source, the mature stage, and the dissipation stage where it dies out. These occur in a continuous process, not as separate and distinct stages. Each stage may occur more than once during the life cycle as the strength of the cyclone rises and falls. It may reach land, weaken, then go back out to sea where it strengthens once more. The formation of a cyclone depends upon the following conditions coinciding: a large, still and warm ocean area with a surface temperature that exceeds 26.5 degrees Celsius over an extended period. This allows a body of warm air to develop above the ocean's surface. Low altitude winds are also needed to form a tropical cyclone. As air warms over the ocean, it expands, becomes lighter, and rises. Other local winds blow in to replace the air that has risen, then this air is also warmed and rises. The rising air contains huge amounts of moisture evaporated from the ocean's surface. As it rises, it cools, condensing to form huge clouds about 10 kilometers up in the troposphere. More warm air rushes in and rises, drawn by the draft above. The rising drafts of air carry moisture high into the atmosphere, so that these clouds eventually become very thick and heavy. Condensation then releases the latent heat energy stored in the water vapor, providing the cyclone with more power. This creates a self-sustaining heat cycle. Drawn further upwards by the new release of energy, the clouds can grow to 12 to 15 kilometers high. The force created by the Earth's rotation on a tilted axis, the Coriolis effect, causes rising currents of air to spiral around the center of the tropical cyclone. It is at this stage that the cyclone matures and the eye of the storm is created. As the air rises and cools, some of this dense air descends to form the clear, still eye as the cyclone rages around it. The eye wall, where the wind is strongest, behaves like a whirling cylinder. Cyclones rotate clockwise in the southern hemisphere, anti-clockwise in the northern. The lowest air pressure in a tropical cyclone is always found at the center and is typically 950 millibars or less. The average air pressure at the Earth's surface is about 1010 millibars. Tropical cyclones have significantly lower air pressure than the air that surrounds them. The bigger the pressure difference, the stronger the wind force. One of the lowest air pressures ever recorded.
Okay, you guys saw the animation here.
Yes, sir.
Okay,
Yes.
now let's
Now, what is millibars?
millibars. It's the unit to measure atmospheric pressure. Okay. So look over here. That's a better depiction here. Now, the warm air is rising up here. Okay. The conditions, first talk about the conditions required for a cyclone to form. First condition is that large still water having a temperature above 26.5 degrees Celsius. The third condition required for generation of cyclone is Coriolis force. What is Coriolis force? It is the force generated due to rotation of Earth. Rotation of Earth. Okay. So just let me give you a glimpse of what Coriolis force actually is. For example, you see this is your North Pole and this is your South Pole. The temperature here is cool, here is also it is cool. It means the pressure is more here, the pressure here is also more. Okay, and in this is your tropical region, Tropic of Cancer. So this much of region is called as tropical region, and since sunlight directly falls here, the temperature here is supposed to be lower. So temperature is supposed to be more. It means the pressure here will be low. Lower pressure, high temperature. So you guys know that the wind is supposed to be moving from a pressure of high region to lower pressure. It should be like this now. From the poles towards the tropical region. But this movement of winds is disturbed due to the rotation of the Earth. So it is not very precisely towards the equator, towards the tropical region. Is that clear, Sundus and Chakrika? So it is little bit deflected towards different direction. If you were to look at this diagram, it will become clear.
Sir, I have a doubt.
Yes.
Like, you said that at like cool temperature, the pressure will be high, right? So it's like, does it does the temperature come from above or from below, like from this northern hemisphere or southern hemisphere?
From both the sides, from in both the northern and the southern hemisphere, the temperature is cooler on both the sides. And the reason for the temperature being cooler here, it's because sunlight does not directly fall on them. Will you please repeat the question?
I mean, like, I didn't understand the point where you said that, I mean, what disturbs like what?
Yeah, exactly. Look here. Suppose now, let's say this here, okay. Let's say this is Earth. Let's assume it to be Earth. Okay. And it is rotating on its axis. All right. Suppose there's a movement of air from this side to this side. Okay, it is supposed to be in this manner, in this straight manner. It should be like this. The principle says this now. The movement of wind should be from a region of higher pressure to
Higher
lower
pressure to
pressure.
low.
Exactly. So this region is having higher pressure. Okay. While this region is having a lower pressure. So there should be a straight movement of winds from high pressure to lower pressure region. Isn't it, Santosh? So Chakrika,
Yes,
you
sir.
see here, if you were to look at this diagram, the movement of wind is taking place in this manner. Again here, if you were to
Not
look
being
at this,
straight.
it is not being straight. It is being disturbed by the rotation of the earth. The earth is rotating on its axis. That is the reason why there is not exact movement of wind in a straight direction here. So this,
Yes.
the rotation of earth generates a force that we call as Coriolis force. Right now. So what will happen whenever there is a generation of cyclone? What happens? The wind starts to move in spiral like fashion. In a spiral direction, it starts to move here. So look over this diagram. Warm air is moving towards the center of the storm here. It starts to rise up. Getting it now? And as it starts to rise up, here the pressure is lower. Already we discussed that moments ago. More and more air will be starting to come towards the center, but the air that is coming towards the center of the storm will not be in straight direction. Why is it so? Because of the Coriolis force. So if you were to look at the directions here, see this here, see the directions. This direction depicts the coming of the air molecules from the surrounding region towards the lower pressure region here. Getting it now? So the air molecules start to move towards the center of the storm in a spiral fashion. And the center of the storm that is having the lowest pressure, that is called as eye wall of the cyclone. Getting it?
Yes, sir.
Okay. So there's a continuous supply of warm air and moisture from this water body, and the cyclone will be alive. It will be continued till it reaches the shore, till it reaches the land surface. Why? Because there it won't be getting the moisture and heat. Getting it now? As compared to water body, there will be lesser moisture. That it once it comes to the shores and the land surface, there is usually a huge amount of rainfall there, and the cyclone is faded there. Getting it now? So we can conclude the steps in the following manner. There is difference of temperature between the two regions. Here, this region and this region are having different temperatures. So suppose this region of the water vapor were being heated up more, so the water started to rise up. So the first process in the formation of cyclone is the temperature difference. All right. This temperature difference will set convection current in the air. You guys know what is convection currents in the topic sand and land breeze. You guys have studied about convection. Yeah. So warm air rises up, it creates a low pressure area, and cool air converges to the low pressure area. Cool area from the surrounding is coming to the low pressure region. Getting it now? And warm air is continuously rising up. Getting it? Warm air is continuously rising up, and there's a continuous movement of colder air in the lower pressure region. So this basically generates a cyclone. Okay, any confusions in this?
No.
No.
Okay. Now, a few more things about it. Cyclone is as we said in this, due to the Coriolis force, the air is moving in a spiral fashion. Okay, and few other things you guys can note. It will be basically occurring at a elevation of 10 to 15 kilometer. Center of the cyclone will be called as eye of the storm or eye of the cyclone.
Like 10 to 15 kilometer. It will rises up of that height.
Yeah, the warm air rises up to height of 10 to 15 kilometer. Okay,
So like it travels like the other region, right? So like how much time will it take to end this structure of the cyclone?
it
Like the
actually
cyclone
it
time to end.
depends. It depends upon the speed wind. It depends upon the speed wind. It depends upon temperature, and it depends upon Coriolis force. So depending upon these factors, the life cycle of a cyclone depends. If the temperature is more, it means more and more water vapor is being evaporated. Okay, there is, it means more amount of generation of cloud will be there. Okay, and uh, and lower pressure will be generated, and then the surrounding airs will come to that lower pressure region in a spiral fashion due to Coriolis force. So it depends upon temperature, and if the Coriolis force at certain region is more, that will also determine the intensity of the cyclone. Yes, Chakrika?
Yes, sir. So we can also consider the speed wind as like the pressure, right, sir?
The speed,
Yeah, like the pressure.
pressure. Yeah, we can consider that also. If the pressure difference is more, the speed at which the surrounding airs will be coming towards the region of lower pressure will be more. Look here. If let's say the surrounding airs which are coming here, look at this diagram. Okay, say here the temperature is, let's say it to be 35 degrees Celsius. Here it is 25 degrees Celsius. Let's assume it to be 25 degrees Celsius. Or now if for another cyclone, let's say for a particular cyclone, the temperature at the surrounding of the lower pressure region is 35 degrees Celsius. Getting it now?
Sir, I think it's about 26, right?
Above, yeah, exactly. It is above, no. The thing here is now, this 26 degrees Celsius, it is for the water surface, for the water body.
Oh, okay, sir.
Okay. So just hypothetically, let's assume that the temperature at the lower pressure region is 25 degrees Celsius and the surrounding is 35 degrees Celsius. Now, if the surrounding pressure for other cyclone is 40 degrees Celsius and here it is 30 degrees Celsius. Okay. Obviously, there's a change. There is a change in the pressure here. Earlier, you had a difference of 10 degrees Celsius. Okay. Now, let's assume it to be 20 degrees Celsius. Okay. Now you are having a pressure difference of 20 degrees Celsius. So it means the speed at which wind will be flowing from high pressure region to lower pressure region will be more. So a lot of factor determines the intensity of a cyclone.
Sir, I can't hear you.
Am I audible?
Yes, sir, now you are.
Okay. So I was basically saying that it depends upon a number of factors. So earlier the temperature difference was 10 degrees Celsius only. Now it's 20 degrees Celsius. Okay. That is the thing here. Okay then. Is it clear or not?
Yes, sir, it is clear.
All right then. No. The cloud region of the cyclone has high speed winds which blow at a speed of 150 to 250 kilometer per hour. Okay. So this region of the cyclone, okay, that is having a low pressure, winds blow towards this low pressure region at a speed of how much? 150 to 250 kilometer per hour. Getting it now? So
Yes,
how
sir.
do you indicate that there's a possibility of development of cyclone? The indication of cyclone can be observed when strong winds start flowing and pushing away the water from the shores. Okay. Now, The cyclone carries a huge amount of energy and it can be very destructive in nature. It results in generation of high waves in sea or ocean because of the low pressure, and these waves can be up to 3 to 12 meter high. Okay. Now, when these high waves hit the shore, it results in the destruction of life and property to a great extent. What is happening here? There is a difference of pressure generated where? Generated in the water body as well. Apart from the air, this generation of pressure difference develop in the water bodies also, and it leads to generation of waves. And the waves will hit the shore, and there will be loss of property in the to the people living in the shore region. The soil will also lose its fertility after a cyclone, because after a cyclone there is heavy rainfall, and that heavy rainfall leads to flood in that region. So the soil's fertility can also be lost. Okay. High speed
Like
winds in the
flood have a
cyclone.
sign.
Yes.
Flood have a sign that shows that the flood is coming. Like the ocean will be silent.
Yeah, that is a sign. If the there's like a calmness in the ocean, normally it is seen that there might be a cyclone. For a long overdue time, it's calmness, then it is predicted. But nowadays you have got various technical instruments that can be used to predict cyclones. Okay. Now, in different parts of the world, the cyclone is known by different names. For example, in American continent, it is known as hurricane. See here in the diagram, in the North and the South America, it is known by the name of hurricanes. Okay. In the region of uh, Japan and Philippines, it is known by the name of typhoon. All these things are same. Whether you talk about hurricane or typhoon, they are just same. They are basically cyclone, but with different names. Getting it?
Yes,
Okay.
sir.
Now let's talk about tornado. What is a tornado? It is a weather condition when a cloud having a dark funnel shape reaches the ground. It's like this.
Is tornado same as thunderstorm?
Tornado and thunderstorm. Sometimes
Like
tornado
the
is
same.
accompanied by thunderstorm as well. Okay, but
They
usually
are
it
not same.
is different. They are not same. They are two different things. They are two different phenomena.
So tornadoes are very rare, right?
Tornadoes are,
Very rare, right?
they are rare. Yeah, they are rare, but is- still you see, it is generated due to several factors. For example, if there is a high pressure difference, if there's a difference, there's a high amount of difference between two regions, then it will lead to development of high winds. Okay, winds with a high intensity will be flowing in that region. Okay. Now talking about its formation, the interesting thing is that the tornadoes can be formed within cyclones. There is a cyclone, and within the cyclone, even tornadoes can be formed. Getting it now? So the biggest phenomena here we are seeing, it is a cyclone, and within that cyclone there can be tornadoes formed as well. Okay. So in a tornado, you see the diameter of a tornado can range from 1 meter to several kilometers. It could be a small one or can be a bigger one as well. Okay. And it can be formed within cyclones as well. The wind here, you will see the speed at which it is blowing, it's 300 kilometer per hour. While in the case of cyclone, what was the speed of the wind? It was around 150 to 250 kilometer per hour. Getting it now?
Yes, sir.
So this funnel-like shape of a tornado, it will suck everything that comes near it at the base because of the lower pressure exerted by the winds. So in this, what is happening? This is the eye, which is having a very low pressure, and the wind is moving towards the center of this tornado at a very high speed, at a speed of 300 km per hour. Right. Now, since the center of the tornado has got very lower pressure, then what will happen? It will be sucking up everything. Just like wind moves from a region of high pressure to lower pressure because there is a vacant space here. In the same manner, a tornado, in the center of the tornado, there is very lower pressure. Hence, it will be sucking up everything that comes into its pathway, whether it be house, whether it be cars, or whether it be any other thing. Getting it now? It's just like
Sir,
whatever come in its path, it eats it away and destroys it. Yes.
so the low pressure is only at the base.
Not only at the base, it is all along its pathway. I mean to say, if you were to look at the height of the tornado from the top to the base, there is lower pressure. Okay.
Oh, okay, sir.
So what will happen now? Usually at its eye, that is at the top of the tornado, the pressure is more lower. So suppose there is a house in its pathway. So what will happen? This tornado will destroy this house and all the components of the house will be taken up to the top of this tornado. Getting it?
Yes, sir.
Okay. So we will stop here then and we will continue in the next class then. Okay.
Thank you, sir. Bye, sir.
All right then. Bye.
Thank you, sir. Bye.